Good afternoon, Mr. Wallace.
Okay, so we've kind of moved on from earthquakes, right? And now we're going to be talking about tsunamis. Tsunamis, if you couldn't tell from the board over here. So we're going to be talking about tsunamis. What comes to mind when you think of the word tsunami? Somebody raise their hand. No?
The Rock.
The Rock? Fair. Yeah, fair. What do you think, Malik?
A big wave.
A big wave, yeah, that's part of it. That's part of it. Brad? Damage, yeah, a lot of that. What else? What else comes to mind? Flooding, yeah, for sure. Gabby?
Like the T times silent.
The what?
T times silent.
The T is indeed silent in tsunami. Why do they need that extra T anyway? I don't know.
Isn't it Japanese?
It is a Japanese word. It is a Japanese word. Well, and maybe this is a little bit of a side thing, but something that you guys maybe either already noticed or are going to notice as we go through and do a lot more of this when it comes to landforms and kind of phenomena in Earth systems and Earth science. Most of these words come from places and from languages and cultures where that thing happens to happen a lot, right? So, for instance, a lot of words for like deserts and desert formations and stuff are either gonna be Arabic or Spanish, right? Because they're the ones that are dealing with that the most. Now, when it comes to glaciers and mountain formations and stuff, a lot of times that's either French, like in the Alps, right? Or kind of like Norwegian, Scandinavian, Swedish words, right? Because in Sweden and Norway, they have a lot of ice, right? So that would tell you what? That this word tsunami is Japanese. What would that tell you? There's tsunamis in Japan. Yeah.
I have one side question.
Okay, go for it.
Have you ever seen the Northern Lights?
I have.
Where is that?
I have. No, you can see them as far, like in Scotland and stuff in certain times of year. Yeah. Well, let's digress. Back to tsunamis, right? So you do indeed see some tsunamis happening in Japan. Yeah, no.
I was gonna ask, like, does the tsunamis correlate or does it have a connection to like earthquake?
Ooh, that's a good question. That's a good question. Does it have a connection with earthquake? What do y'all think?
Yes.
Why?
Because
Why
it's
would
all
y'all
It's like
think
a
that?
disturbance. That's what it can be, like, that's what it causes.
A disturbance in the force, right?
Not sure.
But also,
Yeah.
they can be caused from non-earthquake things too, like if something falls into the water.
Ooh, like what would fall into the water?
A landslide,
Oh, a landslide? Yeah, landslides can cause tsunamis.
an asteroid.
Asteroid, so some sort of foreign body from space can do that. Brad?
The dip of the earthquake causes the water to like change its path.
It does. It does. So when you have that dip from that earthquake, so part of those waves, right? It causes that wave to be transferred into the water and be carried away. Yeah, right?
Is there underwater volcanoes?
Yeah. There are indeed underwater volcanoes and so volcanic eruptions. Really for the purposes of this class, now if you guys decide to go on to my alma mater, Georgia State University, and get a degree in geosciences, you'll learn that there are a few more causes of tsunamis than just these three, but for the purposes of this class, you guys really have named all three. We have earthquakes, landslides, and underwater volcanic eruptions. Those are our three major ones. Brad?
What are the other three?
Oh, there's some other ones. So
Icebergs.
Asteroids, right?
you can have some sort of foreign body from space that can come in. You can have certain types of essentially underwater landslides that can also trigger these things, right? But that's for the vast majority of it. Icebergs breaking off, like large things of glaciers, breaking off, large pieces, large chunks, all at once can send out waves as well, which could be problematic, but all of those are much more rare than the other three.
Couldn't the ice be more common now that global warming is warming up?
I mean, it could. I mean, we did have, well, that would be me stealing my thunder for later on, because we're gonna get to that. And actually, in a couple weeks, we're gonna be getting to that. So I'll save that. But I have a really cool video to show you about it. Anyway, we'll save that video for later. So when these waves do happen, right, these events do happen, so this underwater volcanic eruption, the landslides, or the earthquakes, I want you guys to tell me what's happening in this video real quick. And I want you guys to watch very closely. We're gonna watch it a couple times, it's only a few seconds long. Watch it again. What do you guys notice?
The seafloor is pushing up.
Seafloor, yeah, in this case, which is kind of a funky animation, but it does end up popping it up. Thomas, what do you notice?
Like the wave got big.
It did. It got very big, especially as you get towards the coast, right? Yeah, very good observation. Did you have one? Oh. Yeah, go ahead. Brad.
After it hits land, it just like falls off completely.
Right, it kind of tops out, right?
It was caused by an earthquake.
Yeah, in this case, it was indeed caused by an earthquake. What do you guys notice? What do you guys notice about wave heights? Thomas kind of like hinted at it already. I want you guys to look at the wave height when it's right here and kind of notice like the depth of it, the depth of the water. What do you notice about it?
It's getting higher.
Yeah, but what's the relation there?
The closer the shore it gets, the taller it gets.
Uh-huh. Yeah, closer to shore because it's shallower, right?
So it's
But also like right before tsunami, like if you're at the shore, don't let the waves like get pulled back.
Yeah, and what that is that, so as this wave, so we have our earthquake, right? And it sends a shock wave. Does water compress really well?
no.
If you were to take it and put it into a cylinder and you were trying to push it, does water compress very well at all? No, it doesn't, right? And so what's happening there is that it's being pushed up and down pretty quickly, right? That shock wave is going through and it's gonna hold true. And so as that shock wave goes out, just like, remember our earthquake waves going out in every direction, these waves are also gonna go out in every direction, okay? And the thing is here is that there's no compression, right? So that energy, that big column of energy, the big water column energy, as it goes up, it's gonna stay about the same height, regardless of the surface underneath. And that's how you get that big wave. That's how, as you get closer and closer and closer to shore, it's higher and higher and
How
higher.
does it stay together though?
How does it stay together? It's, I don't wanna, in this class,
Is that a weird question?
no, that's a great question. It's a great question.
Just think on one.
I wanna, like, I can go into it, alright, let's do that.
Is that more of like a physics question?
That's a
Like
little bit of a physics question, right? And so, well, also, like, in college, I literally took a class on waves. So I've got so much stuff bouncing around in my head right now for you. But essentially, right, with your water column, you have this rolling motion, right? And the thing is that they don't really squish. This is the easiest way for me to put it. They don't really squish as they go along, right? They're going to maintain their shape all the way through. And what'll happen eventually, as it comes up, and we'll talk more about this later on, sometimes you'll get a little bit of friction at the bottom, right? But not a lot. But what happens is that eventually they'll get here, and as they go up, that height goes up. Does that make sense? It follows, yeah, it's gonna follow the contour of that shore, right? So yeah. So eventually, you do get to where it will have a bunch of friction because it won't have a lot of energy behind it going this way, and it'll actually roll over. At least in most waves.
Yeah.
At least with most waves. Surface waves.
Most
especially.
waves are caused by wind, right?
Most waves are going to be caused by wind. So somewhat the same motion, sometimes not so much. Where did my eraser go? There's my eraser, Dr. Bill. All right. So, I want to show you guys another video real quick. Is that my computer or your computer, Dr. Bill? No, that's my computer. There we go. What happens when you put stuff in places that you're not used to? All right, I want to show you guys another video real quick. I think I have it on the side. Now, I want you guys to watch this video, and I want you guys to think about in your head all the different things that are happening in this video. Kind of take it all in, and we'll talk about it, okay? It's only 30 seconds long. What are your thoughts?
I feel like as soon as it hit like the surface, or no, it's not lying. As soon as it hits it, it just like breaks down and it spreads apart, you know?
Yeah, yeah. Well, and I think there was kind of like a breakwater there too. That was a bunch. Do y'all know what riprap is? Have y'all ever seen like on a shoreline or like maybe kind of underneath like a bridge overpass? There'll be a bunch of rocks and stuff, and that keeps erosion from happening. That's called riprap. You have that on the coast a lot, but I do see, yeah, it definitely did roll over, right? It did. That's called when the wave breaks. And remember on my drawing how it had like friction at the bottom, so eventually it kind of goes like this.
Yeah.
That's it breaking, right? You see surfers catching the break sometimes, right, as it rolls over the top. You don't want to surf this one though.
I was about to say, has the surfer ever surfaced enough?
Yeah.
I don't know.
It's
I don't know.
Once it gets to shore, it just breaks
That would,
apart.
it would probably be, it would be great until it wasn't, right? That would be really, really awesome until it really, really wasn't.
I'm sure someone's
They have to ride it there.
wanting to try.
So speaking of, why would it, we all know why it would be great to ride a big tsunami wave that seems
But
really
they
cool,
don't know it's a
but
tsunami wave.
why would it, later on not be great? Why do y'all think?
Cause it's gonna break.
When it gets to shore, it just breaks apart, like, you saw in the video, like, all the water just like, just, you know, it's not really a wave anymore, it's more just like flooded water coming in.
Yeah, kind of, right? Yep, yep.
Is it because like, the water is no longer like supported by the pressure like the other water?
Well, in that case, it's still gonna be coming through, right? And you didn't get to see it, cause he was like, oh, time to go.
Like, there's no more
You know.
body of water, so it can't go in, like, in, where there's any.
Most of the time with tsunamis, you do have a lot of water behind them. A lot of times you do. And depending on the intensity of the magnitude of the earthquake, right? That, or the magnitude of the landslide or anything like that, it would increase the amount of water that's gonna be coming in behind it, right? Cause some of these tsunamis, the wavelength, so that's a really short wavelength, right? Do y'all remember wavelength? Yeah, okay. That's kind of a really short wavelength, right? Some of these tsunamis have really long wavelengths. So for instance, the Japan tsunami, which I'll show you a video of that here in a little bit.
There's multiple waves in tsunamis.
Yes, you get multiple waves typically. Where was I? Oh, hazards. What are some hazards associated with? That's what I was really getting at, I think, with the surfer. Josh?
Or for surfing?
Well, just that, not the hazards of surfing, hazards of tsunami.
I feel like normal waves look pretty clear, you know, clean in general. But I feel like if you would see that video again, it does not look clean at all. It looks like it has a lot of debris and all that.
Yeah.
That's probably not, no, that's not gonna help out.
Well, it definitely churned up some sediments for sure. What else? Yep.
Kinda like when we were like going into like structures for, earthquakes. Water is really heavy when it's like,
It's very heavy.
a lot of it. And I doubt since like you're essentially like on sea level, like you're kinda like equal, it's gonna be taller than most buildings and they're not gonna be able to support the pressure.
Yeah.
of the water.
Absolutely, yeah, because you gotta think about water is a little over 8 pounds per gallon. Right? That's significant, right? Have y'all ever taken in a gallon of milk? Milk weighs less than water, so. Water weighs more than milk. So, you think about that amount of mass moving at such a speed, it's gonna take out pretty much everything in its path. And the even worse thing about it, so say Thomas, I'm sorry, I'm gonna use you as an example for this. But,
Okay, I'm okay with it.
good. So, Thomas has a place on the beach, right? He's got a beautiful tiki hut with his palm trees and stuff hanging out, and there's a tsunami coming. Well, it's gonna come and it's gonna take out his tiki hut, which is bad, right? Because he had a wave take out his tiki hut. But now, Riley, oh no, you've got a wave with his tiki hut in it. All the debris from that coming at you. And then, Oscar, you've got the debris from her tiki hut and his tiki hut and other things all coming at you.
If you get caught in it, there's like currents.
And if you get caught in it, it's a bad deal, right? And maybe Riley was cooking dinner and so she had a fire going and then the remnants of her tiki hut and Thomas's tiki hut are now on fire and they're coming at you. Uh-oh. It's a really bad day. It was a beautiful day. We were drinking coconut milk out of coconuts on the beach and then all of a sudden burning tiki huts and waves. It's a really rough way to be.
How do you make coconut?
You have to milk the coconut. You just get up.
Mr.
Like,
No.
you know, I can believe you, like, how I should kind of that right now.
Isn't
Yes.
it true that even after the waves hit, the waves go back into the ocean, taking all that debris back?
Yes, so they're just like a regular wave where they'll come up and then back again. And to kind of cover what Riley was asking about is that, so as that wave rises up, it's pulling water back. And so the way that Thomas may have known that a tsunami was coming is that he's standing out in the water about chest high, and then within about a minute or so, standing on dry ground. This is not good.
Run.
This is not good.
Does it just go back and forth like this?
That's what I heard.
It will,
It's like a
and then
deep
it just
breath.
kind of eventually, and then it'll eventually even back out again. Now, if it's a really large one, that water will continue pushing in, and those waves are really big, so that water will flow a long ways inshore. I think it was 3 miles inshore for the 2011 earthquake and tsunami in Japan.
So if you're,
Bad.
you're right on the water, basically, you will get hit a couple times before it's over.
Yeah, oh yeah,
So after one wave,
It's a bad
another
deal.
one comes, and it's just.
it's a bad deal. Yes, no.
So if you were like chest level in the ocean, and there's a tsunami coming, what is your survival rate?
I couldn't tell you, it depends, it would depend on
How far
How
you
you-
How
what,
good you were at swimming?
how big the tsunami is, how far inland it goes, how much it's gonna drag you inland, and what things inland are there, right? If it's a bunch of trees, then you are gonna be bounced across a bunch of trees, and it's a really bad deal. Or there's a bunch of buildings or other things like other debris like
What
that.
if the pressure of the water itself kills you?
So what?
What if like the pressure of the water itself kills you?
It could. I mean, it could. If it's like one of those big waves that's actually breaking, then yeah, it
Can it
can
break on top of
hit
it?
you. Yeah, that would be a bad deal. That'd be a really bad deal.
That'd be
But-
a bad deal.
The good thing about tsunamis is that we have signs. We have signs that they're happening. We have signs that they
Oh, okay.
are well, that we're at risk for some, right? How would we know that a tsunami was about to happen?
Is there like detectors?
Hold on.
Like if the waves start to pull back, like if you see like you're, or at least like sucking you into the ocean.
Yeah, Thomas noticed that when he was at this imaginary beach in this imaginary scenario that we talked about, where he's standing in chest deep water with his coconut milk, and then all of a sudden, within about a minute, he's on dry land. That's one of the signs. Now, that was kind of one of the old school signs of knowing, right? No,
You know those red things in the ocean?
those red things.
Or like the floaty things?
You
that
mean
There was actually
Like-
one in the video.
like a buoy that floats along in the ocean?
can't- Yeah.
Uh-huh. What about it?
Is that like, can that give an indication that us in
Yeah, it could, especially if you put some kind of measurement instrument there that measured the waves.
Like sonar or something?
No, it's like a little floaty thing.
Yeah,
Measure
yeah,
how-
it
Like,
measures,
it
it
doesn't-
measures how much it goes up and down,
If
right?
it doesn't say like consistent, if it like moves like really like a big amount all of a sudden, then.
Yeah, and so essentially, you can use, they can be fitted with like GPS, right? Where it's going to change, and it's gonna be different from some of the other regular waves as well, right? Because I mean, the ocean always has waves,
Yeah.
always. But, well, almost always. But that's going to move up and down differently. And you would measure that in conjunction with what, do you think?
Elaborate, please.
What else would you use to measure that? Maybe, and this might have been the thing that really kind of like sets off your alarm bells, as it were. What are these stations?
Sonar stations?
Sonar.
Not sonar,
Seismograph.
Seismograph stations, right? Seismographs. You say, oh crap, we got a reading that something big just happened out in the ocean. Uh-oh. Well, we should send out tsunami warnings. We're also gonna monitor it using different buoys. Japan, of course, the originator of the word tsunami, since they do have a lot of those and have a history of them, they have one of the largest networks of monitoring stations anywhere in the world for tsunamis. We're probably second, but their technology is way better than ours when it comes to this. And so they have monitoring stations. So in addition to seismographs, they also have these monitoring stations that monitor the waves, and they can set off alarms. They can send out warnings. We have tsunami warnings as well. Josh?
I was gonna ask, are they on land or on water?
On water. on water. So these buoys are, it's kind of like, imagine like a,
Talking about the labs and all that.
like a net of, so what?
Like,
Stations.
Yeah, stations.
Oh, are you talking about the seismographs? Seismographs are on land. Seismographs are on land, yeah, for sure. Yeah. Well, and then seismographs too, there are a few that are stationed even like underwater, but they are attached to the land, if that makes sense.
Yeah.
But it's pretty shallow, so, good question, very good question. Submarines, yeah. Submarines could, cause especially in the case of like an earthquake or a landslide underwater, sound travels way better through water, and so a lot of times those submarines will hear it before, about the same time that the seismographs are picking them up.
Mr. Lyles,
Yes,
if you're on the beach and you feel an earthquake, that's usually when there's gonna be a tsunami afterwards.
it could, it's a very good possibility. It would definitely be time to evacuate. So, we have these alarm systems, right? We have our own senses as well. What do you do in the case of a tsunami?
You get the high.
That's a question, that's a segue. That's a question that's a segue into our assignment for today. So our assignment for today is that you are going to be creating a PSA, public service announcement. And your public service announcement, of course, has to do with tsunamis. And this could be done a number of ways. You could do it as a poster. You could do it as like a big PowerPoint slide kind of done as a poster, Canva, anything digital. You could do it as an actual poster. You could also do it as a radio show, like a podcast. You could do it as a YouTube short or a TikTok. You could do it, I was gonna say as an interpretive dance. However, good luck, Although I would be very interested. I would be very interested to see that.
I wanna be the wave.
You could do it as a musical. I would, the Tsunami the musical.
Can we get extra credit for that?
The wave is
The wave, the
coming. So, what I want you guys to do is you're gonna go on Canvas. There's some instructions there for you. This will be due on Monday, but you're going to need to include a couple things, right? Because what does a public service announcement do? What's its main job?
To inform the public.
To explain to people, to educate people. So you're gonna be educating them on 3 different things. What a tsunami is, how it works, what the hazards are. Wait, that's 4 things. This is 4 things. And, well, really, those first 2 are the same. And then what to do in case of a tsunami.
Stop, drop, and roll.
So, what is a tsunami? What do you do in case of a tsunami? And what are the hazards associated with a tsunami? Those 3 major things need to be in your PSA. Jesus. Okay.
Going into the basement is bad or going to attic is bad? Which one is safer?
What do you feel like might be the answer to that?
None.
They're both not great.
I mean, not ideal. Well, and actually, we're gonna be talking about natural disasters and hazards. We're gonna be talking about natural disasters and hazards a lot in this class, and this is kind of the first time that these have really, really come up. In a disaster, you do the best you can. Sometimes there are not good options, but you do the best you can to try to survive. So, I don't feel like if you're going in a place that has water, I feel like going up might be the move.
First to the attic.
Yeah, personally.
Like that one movie?
Yes, right. It's the opposite advice of a horror movie. Opposite advice of a horror movie.
So, alerts for tsunamis. I know the video that you showed us, like I heard the other one that was tsunami coming and nobody
It's modern. It's modern, yeah. So assume that your PSA is viewed by a modern audience. Yeah. Okay. While you guys are working on this for some inspiration, I'm gonna put up a couple videos, and some of them are pretty off the rails. I will tell you that they are really off the wall. And it's very, very humbling, I think.